let's try to write a lambda to use in a transform call. Transform is a standard algorithm that transforms one collection into another collection. And it takes a pair of iterators. If I type the open brace, I get these not incredibly helpful IntelliSense prompts. The reason they're not helpful is because of the style of naming convention. So you can tell by what's bolded there, init1 means an input iterator called first, and another input iterator called last. These are the inputs to the transformation. So I know that means I want to transform all of our vector of integers v. So I'm going to say begin at v, comma, end at v. And then there are a series of overloads. The one that I want to use is here, where you'll say the destination. So the destination is going to be the begin of this doubled v vector that I've set up on the line before. And then the last parameter is going to be a lambda of some kind. It just says func here. Let's get rid of that. So let's just be completely, all right, this is a valid lambda. What do you think of that, compiler? And see what it thinks of that. So I'm going to build this. I know it's wrong. There's no way this is right because it didn't do anything, right? But I'm hoping that I'll get some clues from the build errors that I wasn't getting from the IntelliSense. And sure enough, it says, you don't evaluate to a function taking one arguments. Pluralization bug aside, this makes sense. If I'm going to go through vector and do something to it that transforms it, you know, the name transform, and have that end up going into doubled v, it makes sense that I would be handed each element of the vector in turn. And since v is a vector of ints, let's say that we're going to take an int called element. We still don't do anything to it, but let's see what happens. Now it says I can't convert from void to int. It claims that it's doing that on an equal sign. Well, I don't have an equal sign, but again, we can kind of guess that down on line 1043 of the algorithm header file where they have the implementation of transform, there's going to be something like, you know, the current element of this thing is equal to, well, whatever came back out of this lambda. And what comes back out of this lambda appears to be nothing at all, void, that's right. So, now we know we're expected to return some sort of an int. So let's just take the element and double it. Now let's build this. Build succeeded. So with a little bit of trial and error, the build errors tell you what you need to do, even if you didn't read the documentation, or if the documentation was an example involving a functor and you went, oh my gosh, I can't understand that at all, and you couldn't find a decent lambda example, you still get the help from the build errors. Now you're never obliged to capture anything, but if you want to use something from a local scope, you have to capture it. So let's say we wanted to say int factor equals 2, and then in here, instead of 2, let's say factor. In order for that to work, see the red wiggle is I haven't captured factor. It doesn't really matter whether I capture it by value or by reference because I'm not changing it and I'm using it right away. It doesn't have a chance to go out of scope or anything. So I'll just capture it by value. I don't have any red wigglies. Let's run it. And we step over here. Before we run the lambda, we're sitting here about to execute this line transform. You notice our vector v is 0, 1, 2, 3, 4, and our vector called doubled v, we set this up and we passed in a size for it, the same as the size for ordinary v, because I know if there's 5 elements in v, I'm going to need 5 elements in doubled v, so why would I make an empty one and call pushback, pushback, pushback and get potential performance cost of reallocation? I will start with a vector of the correct size. And an interesting thing about that is that it initializes its contents. So they're all 0, not random garbage memory. Anyway, after the transform, if I call step over, doubled v is now 0, 2, 4, 6, 8. So the doubling has worked. We did successfully capture factor by value from the local scope, and we did successfully construct ourselves a lambda that's acceptable for use with the standard algorithm transform. In these early days of lambdas being part of the language, you may not find documentation with lambda examples. The standard algorithms have been around a really long time, and they were generally written by people who were fine with function pointers and function objects, and that's what the examples are. Over time, people are going to start to update them. Until they do, do not forget that the compiler is your friend. And in this particular case, the compiler can hold your hand and walk you through the steps of successfully writing the lambda that belongs as a predicate to this particular algorithm.